In this video, we're going to discuss everything we need to know about a polynomial. Polynomials. You have worked with polynomials in the past, and so some of this will be review. But a polynomial are made up of constants, variables, and exponents. They are also named by their degree and number of terms. Everything that we see with a variable does not mean that it is a polynomial. So these are three cases when we do not have a polynomial. The first one is when we see a variable in a denominator. If we see a variable in the denominator of a fraction, it is not a polynomial. If we have a variable with a negative exponent, that is not a polynomial. Also, if there's a variable inside the radical, that is also not a polynomial. These are the three cases that we got to be aware of when we're looking at polynomials. So this chart right here is something that you need to be very familiar with. It is a way to classify polynomials. We classify polynomials based off their degree and the number of terms. So if you look here in our examples that were provided here, 5. 5 is a constant term because it's a constant term because the exponent had a degree of 0. X to the 0 is 1. We don't write x to 0 because it just means 1. So that's why a constant term will have a degree of 0. Now obviously with 5 there's only one term and it's a monomial. Mono means 1. The next one, x plus 4. Well, we look at the x. The degree on x is 1. So that means linear. In this case we had two terms, so it is a binomial. We have a quadratic here. Again, we look at the highest exponent, 2. 2 means quadratic. Again, there is one term, so it is a monomial. Cubic is that 3 degree. It makes sure it's in order, so there's 3 terms, so it's a trinomial. Quartic means 4, a degree of 4. There's 2 terms, so it's a binomial. Quintic, a degree of 5, and there's 4 terms, so it becomes a polynomial. So, with naming number of terms, we only have a monomial, a binomial, a trinomial, and a polynomial. So those are our only 4 options that we'll name based off terms. But with degrees, we have several. We have constant, linear, quadratic, cubic, quartic, quintic, and then what happens if there's a 6th degree, a 7th degree, an 8th degree? Well, there's no fancy name, and we just say 6th degree. Okay, or 7th degree, or 8th degree, or 10th degree. That's how we name them past 5. Now, one thing you need to be familiar with polynomials is making sure your polynomial is in order. What I mean by that is starting with the highest exponent. So all of these are in order. Like if you look at the last one, it's in order because it starts with the highest degree, 5, goes to 2, then 1, and then 0. So that is in order, but sometimes your polynomials are not in order. It's all jumbled up. So if it is in that case, you need to make sure you're in order before you start naming based off the degree. The number of terms doesn't matter as much for order, but definitely for degree. So always start with the highest degree before you start naming based off the degree. So here's some examples of naming these polynomials. So we need to, make sure that when we are naming our polynomials based off the degree that we are in order. And so what I mean by that is 3n to the third on this first one needs to be written first because we can't name this polynomial based off this -7, saying that this is a constant polynomial. We have to put it in order, so 3n to the third minus 7. That will be the proper order of writing this polynomial. Again, you always start with the highest exponent. So this would be, a cubic based off the degree, and it's a binomial because there's 2 terms. So again, just making sure that you're in order. 5, we already saw that one, so that's just a constant, monomial. And then the last one would be quartic because it has a degree of 4, and it is already in order, and it's a trinomial. Okay, so now we're going to look into operations with polynomials, adding, subtracting, and multiplying. So adding and subtracting polynomials. You have seen something like this in the past before, so this is again going to be a review for most of you. So looking at the first one, we have a plus sign, so that tells you what we're doing, adding, subtracting. So we'll be adding, and when you're adding polynomials, you need to make sure you add like terms. So if you look at the first one, we have 2x squared, negative 2x squared, those cancel, so we're left with nothing there. You're not left with 0x squared, you're just left with nothing because it cancels out completely. Then you have negative 4x and negative 5x, that will become negative 9x. And then we have the constants 4 and 4, and that will give us 8. So negative 9x plus 8 is our final answer. The second one is subtracting, because we look at the sign in the middle. So with subtracting, this is the only one that's different. You have to distribute the subtraction sign to all terms on this side. So now all the signs change. So we have plus negative 9x squared plus 4x minus 3. And then it's the same from here on out. You're going to just, add the like terms. So looking at this, we will have 7x to the third. You see, if you look through the list, there's nothing that goes with 7x to the third. There's not another x to the third, so we just keep it as 7x to the third. Then we look at 6x squared. Well, if you go over here, we do have a x squared term. So again, we're not looking at these anymore. We're looking at the ones that we changed. So that would become negative 3x squared. Again, look at the next one. So we have negative 2x, positive 4x. That will be positive 2x. And then our negative 3 is all by itself because it did not have a like term. So this will be our final answer. And so as you see, as I was, subtracting and adding and all that stuff with this polynomial, I made sure my polynomial will be in standard form. Standard form, it starts with the highest degree 3 and descend from there to 1 and 0. So make sure you are in order when you're adding, subtracting polynomials. Our last operation is multiplying. Now the first one is a trinomial times a trinomial. I'm going to multiply this a little differently than probably what you've seen before, just because there's a lot of terms, and I'm just going to try to use a chart to keep everything organized. So we have a 3 by 3, and so this is the box method, and it's just, again, something that if you want to use it, you can. If not, you can just use, distributive property, and that is okay. But for those who may need to kind of keep your information organized, this would be something good to use. Alright, so what I've done is just I listed the terms, vertically and horizontally based off the two trinomials. It doesn't matter which one goes where because, you're just multiplying. And then you multiply across. So this right here would be negative 4x to the fourth. It's supposed to be a negative. This one will be 8x to the third. This one will be negative 8x squared. So multiply all from this term to everything. Now look at it, negative 5x. So this will become negative 10x to the third. This will be 20x squared. And negative 20x. Okay, and the next one, the last one with 4, we'll have 8x squared, negative 16x, and then 16. And so if you look here at all these terms, everything lines up. All the like terms are diagonally from each other. So if you see here, these are like terms. All of these are like terms. Now I know probably I've kind of wrote all of this, so hopefully you can still see the numbers and signs, but I'm just showing you everything that goes together, all the like terms, and then, after you combine like terms, you just simplify and you'll be done. So negative 4x to the fourth did not go with anything, so that of course goes first. Negative 10x to the third, 8x to the third, negative 2x to the third. If you look here, those two 8x squares cancel out, so I'm left with positive 20x squared. And then come down here, negative 36x plus 16. So we have 5 terms. So we have, a polynomial, a quartic because the highest degree is 4. And so we're done. So this is kind of a big one, but again, you can use whatever method, this box method that we just did, or you could, use your distributive property. The last one, you can use box method if you did like it, it would be a 2 by 2, but if not, just use distributive property and multiply across. So 4x times 3x, 12x squared, 4x times negative 7, negative 20x, negative 15x plus 35. Okay, so with our final result, we will combine our like terms here. So we'll have 12x squared minus 43x plus 35. We're done. Now, the last two are, still multiplying, but this is something that some of us are still missing. And, the 2 on the outside, the squared binomial, what that means is that you have to write it out twice. X plus 3 times x plus 3, and then you would multiply. However, we need to try to do these a lot quicker than just, expanding and then, use the full method. A trick with this is, the 2, yes, you do square the x and you do square the 3, so it becomes 9. But to get the middle term, you must, multiply 3 and x and then double that to give you your middle term. So we need to find quicker ways of multiplying these squared binomials versus the, just expanding and then, using the full method. So look at number 2, we square the 4x to be 16x squared, square the 2 to be 4, but to get the middle term, we have to multiply 4x times 2 and then double that, so that would be 16x. So much quicker versus having you to expand and multiply. So let's try to do that as we see our squared binomials.